So good evening everybody. The Great Moon Hoax. As we're all aware, I'm sure, the moon landings were hoaxed by NASA. We know this to be true because the internet says so. So I think probably the best place to start is what we saw on TV 52 years ago.
Small step for man, one giant leap. No, I guess you want to do it again. Okay. Sorry.
Okay, that probably wasn't the version you remember. That was take 1. You might have seen take 2, take 3 or take 4. But that's the general idea, that the moon landings were hoaxed and everything on TV, all of the cine film, everything you think you know about the moon landings was basically done on a studio set. Perhaps in Hollywood, perhaps Area 51 to keep it more secret, but basically it was a lot of actors bouncing around in white suits. So why do people claim that the moon landings were hoaxed?
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space, and none will be so difficult or expensive to accomplish.
So there you have it, the key words there, impressive and important for sure, but also difficult and expensive. And maybe the advisors that told Kennedy we can do this, maybe the advisors were a little optimistic. Maybe it turned out to be just too difficult and just too damn expensive to actually follow through and deliver on Kennedy's speech. And you can't make the president a liar, even posthumously, and therefore they decided we have to do something about this. We have to fake the moon landings because for whatever reason we can't actually manage it. So plenty of people actually saw a Saturn V lift off, so you can't easily fake that. Yeah. So those things were definitely real. Enough millions of people saw one of these Leviathans lift off the Earth. And it's also not denied that man has been into space, or at least most people who claim that the moon landings did not take place agree that man has been into space. So the Apollo hardware was tested in Earth orbit, and people do believe that there are astronauts on the International Space Station, but that's as far as it goes. That happened, but this didn't. That is not an image of a man standing in front of a lunar module on the surface of the moon. Look closely, you can tell it's an airfix kit. You can see it's made out of cardboard and bits of aluminium foil taken from wrapping a turkey. You can see that he's not standing on the moon. It looks like he's standing on, what is it, plaster of Paris? Another image like this, well, that looks even more like plaster of Paris. And look at the background hills. You can tell they're made of cardboard. So it is clear that none of this actually took place on the surface of the moon. What we're going to do in this particular talk is look at the evidence. If all of these internet sites and various books and magazines claim to have evidence that the moon landings didn't take place, then we should be able to look at that evidence, and that evidence should be able to stand up to scientific scrutiny. So let's see if it does. We haven't got time to look at everything that is claimed about the fakery of the moon landings, but we're just going to pick out a few bits and pieces. We'll look at the claim that computers weren't up to the task, the claim that radiation would kill the astronauts, and we'll have a look at a few videos and a few images. It's actually the images that got me interested because my research is in image processing and image analysis, not of course, specifically images taken during the Apollo program, but images more generally. But I was interested in, if this image is claimed to be a fake, can we actually look at those images, and is there any evidence of fakery, or is there any reason we should believe those images have been faked? So we're going to look at a few items in this list. Firstly, the computers. It's been said many times that computers weren't up to the task. Computers back in the late 50s and early 60s were huge beasts, and they wanted to be able to produce a computer small enough to go into the Apollo command module. What did NASA say? Well, yeah, NASA said certainly computers are quite big, but their solution was to say, right, we want a computer that has a volume of no more than about a cubic foot. It ended up being this beastie, which is inside a copper metal case to protect it from radiation. You can judge the size, roughly speaking, from the keypad on the right-hand side. That's a fairly chunky keypad because it had to be operated by astronauts who might be wearing gloves. So the question that's been raised many times, if that's what NASA claimed to have done, was that sufficient computing power to put a man on the moon? What did NASA do? They went to the best computer experts they could think of, the computing division of the Massachusetts Institute of Technology, and said, we want a computer that fits into a cubic foot or so, and it has to be powerful enough to allow the Apollo vehicle to guide itself to the moon. When they went to MIT, they said, we've got a few years to do this, here's a shed load of cash, get on and give us the computer. So, was it enough? Well, certainly it wasn't the same sort of computer that you've got in front of you, regardless of whether you're looking with a desktop computer, a laptop, a tablet or a phone. The computing power of whatever's in front of you is almost certainly greater than this by many, many orders of magnitude. If you're working on a laptop, that laptop might be doing calculations 1,000,000 times faster than the Apollo guidance computer was capable of doing. And the amount of information your laptop can store is probably 1,000,000,000 times more than this guidance computer. The computing power of the Apollo guidance computer was not so much comparable to modern day technology, or at least in modern day equivalents, it was about the computing power of a musical Christmas card. That probably has got more computing power than what you're looking at there. But was it sufficient to put a man on the moon? It's often said no, simply because it was 1,000,000 times slower than the computer you're using. But that is missing the point. The point is, what work did this computer have to do? And the answer is, it had to effectively solve Newton's equations of motion. If I've got a particular object moving with a particular velocity, and then I apply a force because I fire the engine for a given length of time, how much does my velocity change? And does that take me to where I want to go? That is effectively what the guidance computer is trying to calculate. Newton, of course, worked out the equations, some 400 years ago. And in terms of the complexity of the calculation that's needed, well, we get our undergraduate students to do the calculations, effectively longhand, in the first week of their first semester of their first year of a physics degree. So it can't be that difficult. It's not rockets. Okay, it is rocket science, yeah, okay, but it's not actually that difficult. And a computer that runs 1,000,000 times slower than the computer in front of you is capable of solving the problem and telling you how long you have to fire the engine and when in order to get you to the moon to a precision of a few tens of meters. So whoever says the computing power of the day wasn't up to it simply doesn't understand the task that those computers had. Bear in mind, although I've listed this as a piece of evidence, this is not evidence, it's a statement. To say that the computing power wasn't up to the job is not presenting evidence, it's simply making a statement. The statement is, I don't believe the computing power was up to the job. And the statement is simply false. Let's have a look at another so-called piece of evidence. Radiation. So yes, we know there are radiation belts around the Earth. Energetic particles, positively charged protons and negatively charged electrons, are continuously coming out of the sun, and some of them get trapped by the Earth's magnetic field, indicated by these dotted lines here, and they end up in this radiation belt called the Van Allen belt, or strictly, there's two of them, the Van Allen radiation belts, circling like donuts around the Earth. And it has been said many times that these radiation belts are lethal. Any astronaut trying to get from the Earth to the Moon would receive a lethal dose of radiation. So yes, these radiation belts do indeed exist. They were discovered in the 1950s with the early satellites that were going up. But again, there's a misconception here. Lethal, indeed they would be lethal if an astronaut stayed in the radiation belts. But the astronauts don't spend very long there. Remember, the astronauts are going from the Earth to the Moon. On this scale, the Moon would be somewhere outside your house, and the astronauts are leaving the Earth at a speed of some 25,000 miles an hour. So how long does it take them to go through the Van Allen radiation belts? It might take them half an hour or an hour to go through the belts. I think wherever possible, NASA tried to arrange it so that as the astronauts were going from the Earth to the Moon, they didn't go ploughing through the densest part of the Van Allen belts. They would go a little way north or a little way south. Remember, the Earth is tilted and the Moon's orbit is tilted relative to the Earth's equator. So by arranging the timing, you can arrange it so that the spacecraft goes through and clips part of the radiation belts but doesn't go through the densest region. Yes, the astronauts would have picked up a radiation dose. It might have been equivalent to, for instance, a chest x-ray or two. And the astronauts would have been told that. By the way, if you're going to go to the Moon and come back again, you're going to pass through the radiation belts and you're going to pick up something equivalent to a chest x-ray. And it might, in later life, who knows, it could contribute to an increased risk of cancer later in your life by 1 or 2%. Now, I would imagine that this wouldn't be high on the list of things that the astronauts were worried about. Yes, they would have been aware of the risk, but remember, they're being told, we're going to put you on top of a Saturn V. A Saturn V is 3,000 tons of rocket propellant, and by the way, it was built by the firms who put in the lowest bid. That could be higher on their list of things to think about rather than the possibility of picking up a radiation dose on the way out and on the way back. So again, strictly speaking, this is not evidence. This is a statement. A statement by people who say radiation would have killed the astronauts, therefore they couldn't have gone to the Moon. It is a statement, not a piece of evidence, and the statement is wrong. Let's have a look at a few videos.
Maybe it'll, that's what it looks like it's waving in a breeze.
How many times can a man turn his head and pretend that he just doesn't see? The answer, my friend, is blowing in the wind. The answer is blowing in the wind. Yes, how many deaths will it take till he knows if too many people have died? The answer, my friend, is blowing in the wind. The answer is blowing in the wind.
If ever I ask the question, what do those clips have in common? I have given this talk at a school where somebody said, excuse me, I think what they all have in common is that they're all the American flag. At no point do we see a Union flag fluttering in the breeze there. Well, that's true. But what I was getting at is all of those clips that appear to show a flag blowing in the wind, and you can believe that that might be because they were in a sound studio and somebody left the door open and in came a breeze which blew across the soundstage. But it's more likely that you realise that all of these clips have in common that an astronaut is holding on to the flag or the flagpole. Either it is being planted, or it's being adjusted, or it's being unfurled, but in essentially all of these cases an astronaut is doing something to the flag, and it's simply the appearance of fluttering because of the movement that's been produced by the astronaut holding it. There are other clips, which I'm not going to show you, in which the flag is shown after the astronaut has planted it and left it alone, and there is no sign whatsoever of the flag fluttering in the breeze if it is left alone. There is indeed another little clip you might be able to find where the flag is not so far from the lunar module, and it's thought that some venting of gas from the lunar module might have produced a little bit of a flutter, but essentially all of the pictures I've shown you, which are claimed to be flags blowing in the wind, are of course just being manhandled. Let's have a look at another video which is claimed to be evidence that something is very wrong. Apollo 17, leaving the moon. Why is there no rocket plume? Why is there no exhaust plume?
Proceeded. 3, 2, 1.
An initial flash, but there's no plume from that exhaust. And yet the lunar module, the ascent stage, appears to be rising into the sky. There's just a hint of a little bit of light when it gets really high, but there's no sign of a proper rocket exhaust plume there. And hence it's claimed that, well, that's evidence that it's not really rising because of an exhaust plume, because of a rocket engine. This is simply a model in a studio, and it's probably on the end of a fishing line, and some technician is simply reeling it in and making it appear to rise off the deck there. And the reason people have a problem with this is because they expect every rocket to have a rocket plume. And that's partly because that is what you expect a rocket to look like. That is a proper rocket. Look at that. White hot tongue of flame coming out of the 5 F1 engines there. Subliminally, that's what we tend to think of rockets ought to look like, forgetting about the fact that actually they will only look like that if they're burning a particular type of fuel. In this case, the first stage of the Saturn V is burning not nice and clean hydrogen, it's burning a very dirty fuel, a sort of aviation fuel, kerosene, which is a hydrocarbon. And that is being burnt in the engine combustion chamber, and the byproducts are a whole set of hydrocarbons that are coming out white hot, and they are producing the glow. If you were to burn something else, for instance, if you were to burn hydrogen with oxygen, then the byproduct would be water. And water vapour is essentially transparent, and that's why the shuttle engine exhausts are effectively transparent. For those of you who say, hang on a minute, there's no way you can call that transparent, remember what we're looking at there is the white hot plumes of the boosters. Let's just blow that up a little bit so you can see on the right hand side the exhaust from the solid rocket boosters is indeed white hot, but the 3 shuttle engines, the 3 main engines here, are burning all of the hydrogen and oxygen that's in this orange external tank. And these 3 engines are essentially full throttle, and you can see essentially no plume coming out of the back. It's virtually transparent. Perhaps you can just about see these little blue diamonds, these little triangles in there. These so-called shock diamonds are just shock waves in this almost transparent exhaust plume coming out of the engines that are burning fuel that produce no visible plume. So I'm not claiming that the lunar module burns hydrogen and oxygen, but the point is that depending on what fuel you are burning, you don't necessarily see an exhaust plume. So that explains what we were seeing with the Apollo 17 ascent stage lifting off from the moon. Let's have a look at some images. This is really what first got me interested in this whole idea of the Apollo moon landings being faked. I've seen this picture many times on the internet, usually accompanied by the title, "These shadows are impossible." So what's the idea? Well, if we're looking at the surface of the moon, there should only be one bright object illuminating the landscape here, the sun. Yes, the Earth will also be in the sky in this lunar landscape, but just like from Earth, the sun is very much brighter than the moon. You might think that the full moon looks quite bright, but that's only because you see a full moon at night. If somehow we were able to put the sun and the moon side by side, the full moon and the sun would still be some million times brighter than the moon. And although the Earth is brighter than the moon, the light arriving at the lunar surface, the sun would still dominate by many, many orders of magnitude, perhaps, I don't know, 100,000 times brighter. The point being, you wouldn't get two sets of shadows. You don't get a shadow produced by the sun and separately a shadow produced by the Earth. So the sun should be the only object in the sky illuminating this landscape. And if the sun is a long way away, and on the scale of the few hundred meters we're looking at here, the sun is virtually an infinite distance away, okay, 93 million miles or 150 million kilometers, not quite infinity, but a huge distance compared to what we're looking at here. So if the sun is that far away, it should produce lots of shadows that are parallel. And those parallel shadows should either appear to be parallel, or perhaps they appear to converge at a distant vanishing point on the horizon. So let's have a look at what the shadows are actually doing. We can't actually see the shadow of this astronaut, but we can clearly see the shadow of the lunar lander off to the right, implying that the sun is somewhere over on the left-hand side, pointed to by that red line. And if we look at the shadows in the foreground, let's pick the rock on the right and draw a line through its shadow, we find that that means the illumination that is consistent with those two shadows must be there, just to the left of the astronaut. That can't be right, that's not where the sun is. Not only that, but if we look at the shadow of the other rock, it doesn't even go to the same place. How can you claim that there's only one source of light on the lunar surface here and then have these impossible shadows? Well, I said that if the light's an infinite distance away, it should produce parallel shadows. That's right, except for one circumstance. And that circumstance is easily demonstrated by some clever fellow who set up an analogue of this on his kitchen table. He produced a little model of the lunar lander and illuminated it from a light that's a long way off to the left-hand side. And the reason there's a marker pen sitting upright closer to the camera is to show you that its shadow is in the same direction. Its shadow is parallel to the shadow of the lunar module, indicating that the source of illumination, in this case a spot lamp, is actually a long, long way off to the left. But look at what he's got in the middle. He's got a couple of rocks sitting not on the flat kitchen table, but sitting on a little mound of plasticine. So what's happening to the shadows? Even though they're the same shadows from the same source of light, those shadows are now not falling on level ground, those shadows are falling on one side of the plasticine mound. And hence they now look to have rather jaunty angles. And I hope you agree that when you look at that little model and compare it to the main photograph, you can see the various angles of the shadows basically all agree. Those shadows are perfectly reasonable shadows as long as you accept that the moon's surface is not absolutely dead flat, and there could be the possibility of some undulation. Maybe there's a little mound there on the right-hand side. It's a two-dimensional picture, not a three-dimensional picture, so you can't see the actual topography, but it is not unreasonable to assume that there is a little bit of undulation in the surface of the moon, and that easily explains those shadows. So we invoke Occam's razor, which says if there are two explanations for the same thing, maybe the simplest explanation is the right one. So one explanation is the lunar landings were faked. The other possibility is the moon's surface is not dead flat. Perfectly reasonable assumption. Okay, what about this picture that I showed you earlier? Again, this is shown many times. Where are the stars? Why are we looking at a picture that's supposedly taken on the surface of the moon, and yet there are no stars in the background? It is said, surely if there's no air on the moon, the stars must be really, really bright there, and so a picture would show lots of stars in the background. Well, actually that's wrong for two reasons. Firstly, if you think about what would happen if you took the air away, would the stars be much, much brighter? Well, that assumes that the Earth's atmosphere absorbs a lot of the visible light that's arriving. Well, clouds tend to, but if we ignore clouds for the moment and just think about the transparent atmosphere, actually, the atmosphere, even 10 or 20 kilometers of atmosphere, doesn't actually absorb that much visible light. Yes, it will absorb some, but taking the atmosphere away wouldn't make the stars 10 times brighter. It wouldn't even make them half as bright again. It would change their brightness by a few percent or perhaps a few tens of percent. But remember, the reason our eyes have adapted to visible light is simply because most visible light does arrive at the surface, unlike, for instance, infrared or ultraviolet light. So firstly, it's wrong to say that because there's no atmosphere, the stars would be brighter. Okay, let's assume the stars are the same brightness as we would see from Earth. Why does this picture not show any stars at all? There are some images that might show the Earth in the background if it happened to be pointing in the right direction, but these sorts of images don't show any stars. Anybody who says it's unusual not to have stars has possibly never taken a photograph on Earth in their lives. Because I'm sure you realise that if you were to take a picture on a sunny day, and indeed it was a sunny day when they landed, no clouds on the moon, so every day is a sunny day. So if you're taking a picture of a man in a white suit in front of a gold-covered craft, what sort of exposures might you have? Well, these aren't recorded because this is, of course, photographic film, slide film, Ektachrome film, rather than digital, so we don't have a record of what exposures were taken. But I would think on a sunny day you might expose for perhaps 1 millisecond, 1/1000th of a second, depending on what aperture of lens was used and which particular film was in the camera. If you're taking a picture of 1/1000th of a second, for instance, if you tried that on Earth at night, you would not pick up stars. Anybody who's dabbled with astrophotography knows that if you want to take pictures of stars at night, you open up the lens as far as you can go and then you expose for, well, essentially as long as you can. A picture like this behind me, taken of the Milky Way, might have been quite a few minutes exposure. The difference between 1/1000th of a second and many, many minutes, that's perhaps a factor of about 1 million or so. In other words, the exposures here are perhaps 1 million times too short to get nice images of the stars in the background. So perfectly reasonable that there were no stars. But you can turn the question around and say, well, if you do believe this is in a studio and not on the surface of the moon, if you do believe that NASA faked this and produced those images, why did NASA do it in a studio in which the backdrop was perfectly black? Why did NASA not paint the stars on the backdrop so that we then had stars visible in this image to make it more realistic? Well, people who believe in the hoax would say, yeah, this was taken in a studio, but NASA did not paint stars in the background because they didn't want to put the stars in the wrong place. They didn't want to paint stars in the background and then have 50 years later somebody in an astronomical society coming along saying, that is Arcturus, that shouldn't be there when this picture was taken. Well, if you really believe that NASA does not know where the stars ought to be at any given time, you have a really low indication of what NASA can do. And therefore maybe you do believe that they can't possibly put a man on the moon if they really don't know where the stars ought to be in any given photograph. Let's look at another image. Aldrin, standing not far from one of the legs of the lunar lander. You can see that Aldrin has been walking around a bit and he's left lots of footprints that seem to be at least 1 centimetre or 2 into the soil. And yet the lunar module landing leg does not appear to have gone into the lunar soil, the lunar regolith, at all. If you work out the area of the boot of an astronaut and work out the mass of an astronaut to work out the pressure pushing down into the regolith, you can do that for the astronaut, you can do that for the lunar module. The pad, of course, is much bigger than his boot, but the lunar module has a larger mass than an astronaut. The lunar module might have a mass of about 15 tons, minus the fuel that was used to get down there. When you work out the pressure under each of the landing pads, it's not so different from the pressure underneath an astronaut's boot. So if an astronaut's boot goes down a few centimetres, why doesn't the landing leg? So this is claimed to be evidence that this picture is not a real picture of an astronaut on the surface of the moon, because the footprints give the game away. Or there's another explanation. When you ask the question, why didn't the landing leg sink into the soil? The answer is, it did. But not in that particular picture. It's obvious in that picture that that leg has gone quite a few centimetres into the regolith, into the surface there. And indeed, when you look at all of the images from the Apollo records, you'll find some clear evidence that the landing legs did sink into the soil, and every once in a while you see evidence that they hardly sank in at all. Perhaps there wasn't that much dust in this region, even though on the left-hand side it's clearly quite dusty and footprints have been left. So this is not that unusual to find, that when you look at internet sites or books or magazines that say, here's evidence that something is wrong with the images, it is not unusual to find that they present the image which backs up their claim, something looks odd, but of course they will not give you the counter-argument of presenting you with images which shoot down their argument. And that is part of the problem about people being very selective with evidence. If you believe something is true, you might collect the evidence and only show the evidence which backs up your claim. And if anybody comes along with any counter evidence, you either ignore it, or you close your eyes, or you claim that that's not relevant for some particular reason. My personal experience is that those people who believe in conspiracy theories are quite willing to accept all the evidence which backs them up, and are unwilling to look at any evidence which doesn't. What about the cameras themselves? The cameras that were used on the surface of the moon were Hasselblad cameras. NASA went to the Swedish Hasselblad camera manufacturers and said, make us some cameras that will work on the moon, and arrange it so that we don't have to carry them around in our hands. Let's fix them to the front of the astronaut's suit. So I blow up the picture in the bottom left there to make it a little easier. Hasselblad made versions of their camera with no viewfinders. There's no point in having a viewfinder if you're in an astronaut suit and the camera is in front of you and you can't look down. There's no point in having a viewfinder there. So the astronauts simply got used to pointing the camera in the direction they were interested in photographing. And Hasselblad changed some of the design, for instance the lenses. Remember, the cameras are manual, there's no auto exposure, there's no auto iris, and there's no auto focus. So the astronauts had to set all of these, but rather than the standard way of doing it, which is gripping a ring around the lens and twisting it with gloved hands, that would be awkward. So Hasselblad added these paddles, which made it easier to push this way or push that way without having to grip a ring. So the astronauts basically got used to operating the camera in this particular way. One of the useful things about this picture is we can see these large black crosses that occur everywhere on all of these images. And because I've zoomed in this particular region, these black crosses are fairly large. These are called fiducial crosses, and they're there for a number of different reasons, but mainly to provide calibration so that when you look at the original image, you can tell A, if it's been cropped, because you know how many of these crosses there should be in every image. Actually, the center of the image is a larger version of this, so you can tell where the center of the image is. And if you're looking, for instance, at a particular image and you want to know how big a rock is, if you can estimate how far the rock is from the astronaut, then you can use these fiducial marks as sort of calibration distances, if you like. Why am I telling you about these black crosses? Because the black crosses are in the camera. And hence, when you look at an image like this, again, we can see, hopefully you can see in your image, lots of these black crosses everywhere. Perhaps you can see that this one down here, where my cursor is pointing at the moment, this is the largest cross in the entire image. And that tells us that's the center of the image. The original image was square, and that's its centre, and I've taken the bottom of the image away because there's loads of regolith that's not very interesting. The lunar rover was in the top part of the image, and so I've cropped the original square image down to a rectangle, and we can tell that from the fiducial marks. But the fiducial marks themselves are in the camera. So if you imagine photographing this scene, light from the sun is hitting the astronaut and the rover. It's reflected off those and then goes through the lens. Before it arrives at the photographic film, it goes through a glass plate onto which is etched all of these black crosses. So the black crosses are in the camera. So what can't happen, for instance, is this. Let me blow that up so you can see it a little more clearly. The black crosses are in the camera, so the black crosses cannot be behind any object that's visible in the image, such as, for instance, the white antenna on top of this part of the lunar rover. So, unlike some of the other images I've seen where people have said, the shadows are the wrong angle, or the light seems to be filled in, or there's something wrong with the reflectivity of the soil or the regolith, unlike most images in which you can instantly say, no, that's not fakery, that's just the way it is, or there's a good reason for that, or there's a simple reason for that. This is one image where I first looked at it, where somebody was saying this can't happen, and I looked at it and thought, yeah, you're right, that shouldn't happen. You can't have black crosses behind objects. And so that got me thinking, how can that happen? And the solution takes more than a few seconds thought, because you have to have some knowledge of photography to work out what's actually going on. It's not actually a function of photographic film. It could actually, in principle, happen with digital photography as well, but you don't often notice it. And again, the best explanation I've found is not a detailed explanation of the technicalities. It's an example of how you can reproduce the same thing. So somebody went into his back garden and photographed, you can see a little bit of grass here, a bit of rockery. They photographed a washing line. So here my cursor is just tracing out this faint line, which you probably can't see in front of the grass. I hope you can see this faint line in front of the grey card. The washing line is in front of grey card and white card. You can see the washing line when it's in front of the grey card, but when the washing line goes in front of the white card, what happens? The washing line almost disappears. It becomes much fainter. And maybe you can see it, maybe you can't, but it is much fainter than the very clear washing line in front of the grey card. And that gives us a hint as to what's going on. Whenever you get a very bright region of the image, such as the white card in the inset there, or the white antenna in the right-hand inset, it is saturated white, it is overexposed. And when that happens, the chemical reaction that has produced the particular white result there can bleed out into neighbouring grains of the chemical emulsion and start to fill in some of the black regions. So the black cross, the black line, should be black, but it's getting filled in because white, if you like, is bleeding in from the neighbouring grains of film, simply because it is overexposed. If you had a CCD camera, a CCD chip, you might actually see the same thing, because as the individual pixels of the chip are filling up with electrons because of the light arriving, when a particular pixel is full, it might avalanche out and start to fill neighbouring pixels. So you can get this same effect of bleeding from one grain or one pixel to another. And the other piece of evidence that tells you this can happen is the fact that whenever you do see a black line that appears to be behind an object in the field of view, it's always a saturated, overexposed white object. You never get these black lines trying to hide behind a medium grey or a dark grey or a slightly coloured object. If the black line appears to disappear, it's because it's been filled in by a saturated white object. So the explanation there is not quite as obvious as some of the other images which are claimed to be impossible shadows or other reasons that these can't possibly exist. This one does take a little more of a technical explanation, but once you understand a little bit about how photography works, you realise it's a perfectly plausible explanation. If the cameras didn't have viewfinders, how did the astronauts get such perfect framing? I'm sure you've all seen this image. If I was doing this live, I would ask for a show of hands, but it doesn't really work for Zoom. So I'll just invite you to think, is there anybody in the audience that has not seen that image before, taken 52 years ago? And whenever I ask this question, if I ask it of school kids, I get a few hands go up. If I ask it of people of a certain age, basically everybody says, yep, that is the iconic picture, which of course everybody has seen. But in answer to the question, how do you get that framing so good, we can have a look at a couple of images, one of which is the image I've just shown you on the right hand side, the iconic poster boy of the Apollo program, Aldrin. But on the left I've shown you a different image in which clearly I've cropped it differently and I've sized it differently. So clearly it's a different size, clearly it's a different crop, because one of them is square and the other one is rectangular, and I've taken a little bit off the bottom of the rectangular one to make it fit and to make Aldrin roughly the same size in both of those images. They were taken, I think, a couple of minutes apart or so, and there is something fundamentally different about those two images that is worth pointing out. Now, yes, Aldrin, of course, is not in quite the same position. In one case, he's facing the camera. In the other case, he's slightly angled to the camera. In one case, he's got two hands down. In the other case, one hand has been elevated slightly. But in both cases, the sun is over his left shoulder and he's casting a shadow down to the bottom right. But there is one observation we can make that causes us some concern. I'll just give you 2 or 3 seconds to think about what that might be. The problem is his radio antenna. Clearly visible on the left-hand side, apparently disappeared on the right-hand side. So this radio antenna is basically covered in white plastic and is visible from all angles and is sunlit. So it must always be visible, assuming we haven't dodged around too much with the brightness and contrast of the original image. So if that radio antenna is there, he can't possibly have snapped it off in this image. It's only 2 minutes later, but I suppose that's still possible. But if that antenna wasn't there, then he would have lost radio contact, and you can't have a man running around on the surface of the moon if they are not in radio contact with their fellow astronaut or the mothership or Earth. So what's the explanation for why that antenna appears to be invisible even though it should be there? Well, we're coming back to the framing. How did they get perfect framing? Well, the second clue that tells us something is very odd is looking at that thing that's been circled, which is the largest of these black crosses, which possibly doesn't show up too well depending on the screen you're looking at. But that largest cross tells us that is the center of the image. That is the center of the square image. All of the cameras produced a square image. So if that's the center, but clearly that is not the center of that square, and that gives us the second clue as to what's actually going on. Because that image there is not the image of Aldrin taken by Armstrong on the surface of the moon. The original image, if you go to the NASA archives, is not that one, it's that one. When Armstrong took this picture of Aldrin, he cut his antenna off. Sounds more painful than it actually is. In other words, Armstrong was actually taking a picture of Aldrin's right foot when this picture was taken. Why was that? Well, a number of reasons possibly. Perhaps Aldrin was on slightly higher ground than Armstrong. Maybe Armstrong was leaning slightly. When you look at some of these images, you notice that the astronauts do tend to lean slightly. They've got a 100-kilogram backpack in their life support, so that means they tend to tilt forward slightly for their center of mass. Yes, of course, it's 1/6 gravity on the moon, but that still doesn't change where their centre of mass sits. And so with a large, effectively, person on your back, that means there's a tendency to lean forward ever so slightly. And as the camera is strapped to his chest, maybe that's why the camera was pointing slightly down. Armstrong couldn't tell because he hasn't got a viewfinder. So how did they get perfect framing? They didn't. Sometimes they got lucky, sometimes they got unlucky. In this case, unfortunately, Aldrin's top of his helmet, his backpack, got chopped off. But NASA really liked this photo. But the next one, they said, well, let's have a look at the next one to see if it's better framed. Unfortunately, the next one, Armstrong has gone off to do something else, either photographing the equipment or the regolith or the lunar module or something else, but he didn't take another picture of Aldrin in that pose. So that was the only one NASA had to work with. So NASA said, okay, that's the picture we want. That's the poster boy of the Apollo program. Look at that. Astronaut on the moon reflecting Armstrong in the visor and the lunar module reflecting in the visor as well. So that's the picture we want. So given that aesthetically it looks horrible because we've got a lot of regolith in the foreground and we've got the astronaut pushed up to the top of the frame, what we're going to do is basically lower the picture and simply replace the top with a band of jet black. Remember, when it comes to do we have to put the stars back? No, there aren't any stars in the background. So you don't have to worry about the stars lining up. It's a jet black sky. You just need to put a jet black rectangle in the background and your job's done. I'm sure they then had a committee meeting when they said, excuse me, should we paint his aerial back in? Well, that of course, given that you haven't got Photoshop in 1969, that would have meant printing off the image as large as possible, getting an artist to come in and paint the antenna back in again, and then re-photographing the image. They decided not to do that. They just left that as the picture that would appear on the front of Time magazine and of course would go around the world as the picture of the Apollo program. After all, who's going to notice? It's not like 50 years later we're going to find astronomical societies pointing out the fact that his aerial appears to be missing. So it was no big deal, but NASA admitted that that is the one picture that they doctored purely for the aesthetics of not wanting to have the astronaut pushed up to the top of the frame because it simply did not look nice. So I've told you a few things about some of the so-called evidence that people use to say the moon landings didn't take place. But the big question remains. Turn it around. Is there any evidence that we can put on the table that can prove beyond any reasonable doubt that the moon landings did take place? Well, that depends on your definition of reasonable. As I mentioned earlier, when you talk to a conspiracy theorist, they might say, here's the evidence that the moon landings were faked. But if you try and say, well, yes, but here's lots of counter-evidence, let's look at the evidence and counter-evidence, let's make a reasoned judgment, that doesn't always how a conversation go when you're talking to a conspiracy theorist. They'll gladly take the evidence that backs them up. They won't be too keen to look at the evidence that doesn't back them up. So a reasonable discussion sometimes is difficult to take place. Is there anything we can do? What about the often quoted video that is proof that it was done on the moon?
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here and hopefully they'll hit the ground at the same time. How about that? Mr. Galileo was correct in his findings.
Mr. Galileo was correct. The hammer and the feather hit the ground at the same time. That is sometimes quoted as being proof that that must have been done on the surface of the moon, in this case, Apollo 15. But is that actually proof? Well, how do we know that that is actually a hammer and a feather? How do we know that the hammer isn't made of plastic and is really lightweight? How do we know the feather isn't made of lead and painted white? A hammer and a feather would hit the ground at the same time if you're either in a vacuum on the moon or if they were both heavy. The only reason a feather would normally flutter down and land after the hammer is if the feather was much lighter and falling in an atmosphere. But maybe this was carried out in an atmosphere, but it's not actually a hammer and a feather. After all, how do we believe this person in a white suit? If he works for NASA, of course he's going to lie about it. So simply having his word for it is not enough. Conversely, you could say, even if it's a genuine hammer and a feather, all we would need to do is to put the actor in the suit in a big vacuum chamber, and then we could video that and it would behave the same way as on Earth. Okay, the gravity would be different, so we'd have to change the frame rate of the video or the cine, but that's easy to do. So maybe that could have been filmed in an enormous vacuum chamber. Whether you can get an actor to do that, that's another matter. The vacuum chamber would have to be many, many meters across, many meters in depth, and quite a few meters high, but technically that's not impossible to do. The closest I can think of as proof, which arguably is not 100% proof, but it's as close as you can get, is a video. This one has no sound. It's a video, I think this one could be John Young in the lunar rover here. It's part of a very long clip in which the lunar rover travels an enormous distance, many, many hundreds of meters. Why do we think that was carried out on the surface of the moon? Why was that filmed on the moon? Well, it was almost certain, no, not almost certainly, it was certainly filmed in a vacuum. How do we know? Because if you look in detail, frame by frame, which we're not going to do here, frame by frame of the original cine the cine film, if you follow frame by frame, you can see that the dust that's kicked up by the wheels doesn't billow in the same way it would if it was in an atmosphere. Each tiny grain that can be seen on each frame of the original cine film flies up and follows a parabolic orbit and then lands again. None of them seem to billow in the way you would expect if this was being filmed in an atmosphere. So, detailed analysis tells us that was filmed in a vacuum. But you can come back to the previous argument, well, that could be done on Earth and the video rate changed, the frame rate changed. All we would need to do is to put the astronaut and the lunar rover inside a vacuum tank, 1/2 kilometre long and tens of meters wide and perhaps tens of meters high. Well, how would you get a vacuum tank that volume pumped down in a reasonable time? If you put the astronaut in and then start pumping it out, I don't think you could pump down that volume with the technology that existed in the 1960s. It is not impossible, but I believe it is technically difficult. And I would argue that technically it's more difficult to fake that on Earth than it is to send a man in the moon in the first place. So it would have been easier just to do it on the moon than it would have been to do it on Earth in a large vacuum tank. So that piece of evidence, I think, is the closest we get to you can't fake that. Some people claim that it's evidence because if you shine lasers at the moon, they bounce off these corner reflectors that have been placed at various sites on the moon. Bouncing lasers off the moon has been carried out, I believe, every day for the last 52 years. And hence the distance to the moon has been calculated because we know the speed of light. So if you time how long it takes for the pulse to get there and back, you've got the distance to the moon very accurately, to an accuracy of, I think, a few centimeters or so. And if you've got different sites on the moon and you can get those measurements independently, then you've got the distance from the Earth to 3 separate positions on the surface of the moon. So not only do you know the distance, you know how the moon is wobbling backwards and forwards or nodding up and down. You've got very detailed data about how the moon is moving around the Earth, which helps us, of course, understand gravity. Is that proof that man has been to the moon? No. It's arguably proof that there is a set of laser reflectors on the moon. They could have been placed there by robots, by satellites dropping them onto the surface of the moon. It is not proof that a person placed them there. So that's not proof either. Another common example of this is obviously a fakery, because if NASA did go to the moon, and they wanted to make it clear that they did go to the moon, why don't they just turn the Hubble Space Telescope with its fantastic resolution towards one of the landing sites on the moon and take an image of the lunar module sitting there? NASA have never pointed the Hubble Space Telescope at the moon for that reason, it is said, because they wouldn't want to show that there are no lunar modules or no flags or no footprints there. Well, that's one argument, but Occam's razor again gives you a simpler explanation for why NASA has never turned the Hubble towards the moon. Regardless of whether you believe the hoax or don't believe the hoax, everybody has to obey the laws of physics. And if you work out the resolution of the Hubble Space Telescope, if you don't like numbers, look away now. The resolution of the Hubble is given by the wavelength of light it's working in divided by the size of the mirror. So wavelength of visible light about half a micron or so, the size of the mirror 2.4 meters, divide one by the other, the resolution, the smallest angular thing you can make out, is about 0.2 microradians, 0.2 millionths of a radian. We can convert that to degrees and that turns out to be 10 millionths of a degree. Of course, being astronomers, we tend to think in terms of arc seconds, so we get a resolution of the Hubble of about 0.05 arc seconds. But remember just how far away the moon is, 400,000 kilometers. If we want to see an object that's a few meters across, let's say 4 meters for the sake of argument, let's imagine the lunar module is 4 meters across, it's at a distance of 400,000 kilometers, then what's the angular resolution we need to see 4 meters at that distance? We would need an angular resolution of about 0.01 microradians or 0.002 arc seconds. The resolution we need is far smaller than the Hubble can achieve. Yes, the Hubble is a fantastic telescope and has a great resolution, but the moon is so far away we couldn't possibly see the lunar module. It's too small by a factor, if you divide one by the other, too small by a factor of about 30. So either the lunar module would need to be 30 times bigger, or to see the lunar module on the surface, the Hubble mirror would need to be 30 or so times bigger. In other words, the Hubble mirror would need to be about 100 meters in diameter to have the resolution that would just make out the lunar module. Remember, that means the lunar module would be 1 pixel in the image. No flags, no footprints, but you would just make out the lunar module as 1 bright pixel in the image. So we're a long, long, long way from having the Hubble Space Telescope prove the landing site is there. Since then, there have been other ways of looking at the landing sites from an orbiter around the moon, but that orbiter was owned by NASA, so of course they faked those images as well, haven't they? I showed you this image earlier. Let's just make it a little bit bigger so you can see it more clearly. We have some odd things going on in the top left-hand corner here. Because the sun is over the astronaut's right shoulder, the sun is shining into the camera lens to some extent, and the pentagon, which is the iris shape of the aperture in the lens, is causing this odd pentagon shape next to the astronaut's head, and this flare in this extreme top left. If we ignore that, because that's a known photographic flare, there is something that is very wrong with this image. Some people have pointed out that the aerial isn't very distinct. Well, that's true. I have adjusted the contrast of this image to make it a little bit clearer, and in doing so I've made it rather difficult to see the aerial that's sticking up on his life support pack there at the back. So apart from the aerial and apart from the glare in the top left of the image, what is wrong with that image? Again, just a few seconds to think. Some people pick it up immediately, and some people stare at this and think, well, I'm not too sure. Is it the angle of his arm? Is it the reflection of his arm? Is it something to do with his camera? No. Have a look at his visor. What do we see in his visor? If this is Alan Bean that we're looking at, the astronaut that we're looking at, he's been photographed by Pete Conrad there, whose camera is pointing at the astronaut. So if this is Bean and this is Conrad, who is this joker on the surface in the background there? Who's the third guy? Is this a stowaway that came down with the two astronauts, remember, of the three-man crew in the Apollo system? One stays in the command module in orbit and the other two come down to the surface. So on this occasion, did they have a stowaway? No. This must be a fake image. And I would absolutely agree with that. This is quite definitely a fake image. And the reason I know quite definitely it's fake is because I faked it. I went to the NASA archives, I downloaded a very nice image of Alan Bean on the surface in Apollo 12, and that image was this one. And I took that image and I said, there's a nice space there on the left-hand side. If I find another astronaut, and if is the wrong way around, if I flip him over and adjust the contrast and adjust his size and place him in that position and then tidy up the horizon in the background using some graphic software, then I can make it look like there's another astronaut in the background there who seems to be the right height, casting the right shadow in the right way. But that's what the original image looked like, and it took me a few minutes to fake it and add an entirely new astronaut. And if you didn't know that there could only be two people on the moon, you might be convinced that that image looks perfectly reasonable, and if you zoom in, you don't see anything that tells you this image is obviously fake. Image editing software is good enough that essentially you can fake any image you like. Which is a bit sad, because that means anything you see on the internet you cannot believe. Perhaps you believe it if it comes from a reputable source, but by looking at an image you cannot tell that image has been faked. It was very difficult to fake images back in the 1960s, but now we have the digital tools whereby it is easy. And of course we can go beyond faking images to faking videos if we so wish. I mean, you know this, of course, because you've been to the cinema, you've seen sci-fi, or you've seen dinosaur films. All of them are absolutely fantastic, and you cannot tell, compared to the films of the 1950s, for instance, you cannot tell that what you're looking at is not real. So that means when we look at the internet, not only must we be suspicious of fake news, we have to be suspicious of every image and every video we ever see. When I was young, I knew what was real and what wasn't. I looked it up in Encyclopedia Britannica. If it was there, I knew it was right. These days, you have no such luxury of anywhere that is known to be absolutely reliable. So it's a bit of a shame. But what is the point? Why are there so many people who believe in the moon hoax conspiracy? Do these people really believe that the comments and the evidence that they're presenting really do stand up to scientific scrutiny? Do they really believe it's scientific evidence rather than just hearsay and comments and opinions? Well, most arguments, as you've seen in the last hour or so, most arguments can be countered with some basic physics, and sometimes not even that. Sometimes it's just common sense, let alone basic physics. Sometimes the analysis of the evidence actually makes a good science lesson, and I'm pleased to see that sometimes some teachers are using it as a way of teaching the scientific method. These people are making this claim, this hypothesis, using this evidence. If we look at that evidence, does that evidence actually back up this claim, this hypothesis? So good on the teachers that are using this to positive effect. Sometimes thinking about how things behave on the moon helps you think about how things behave on Earth. So there's some good to come out of all this. So next time you see that image, wherever it may be, if you're with somebody who isn't at this particular talk, you can point at that and you can say, "Ha-ha, I know that that is not the image of Aldrin taken by Armstrong on the surface of the moon during Apollo 11. And you can tell them why. Thank you very much.